So chapter 7 is all about data analysis, and we start right away in 7.1 with measures of center and variation. So if you take a look at the top of the page, we have 3 vocabulary words. You probably or hopefully have heard of these words in the past, but let's review the meaning and how we find each of these. So our 3 words are mean, median, and mode. Let's start with the mean. The mean is the sum of all the data divided by the number of data values. And we represent it, or we're going to represent it with something called X bar. So X bar looks like this. It's an X, and then it has a line on the top. That's called X bar. You'll hear me say that. You'll see that. Whenever you see that, that means mean. And then let's write the definition for mean. It's the sum of all data values divided by the number of data values. Again, mean is hopefully something you've heard in the past. We actually have another word for mean, which you might be more familiar with. You might have heard more often. The mean is the average. So when we're talking about the mean of the data set, we're talking about the average, and that can be a really, really useful piece of information. The median, so if I had to use one word to describe mean, it would be average. If I had to use one word to describe median, it would be the middle. It's basically the middle value. The key here is it's the middle number when the values are written in numerical order. So you have to have your numbers in order and then find the middle. So the median is the middle number when values are written in numerical order. Remember, numerical order basically just means they're in order from least to greatest. I suppose it could be greatest to least, but they have to be in order to find the, oops, that's not how you spell numerical. We'll add an N in there. Numerical order. And then the mode is the value or values. There can be one mode or there can be more than one mode. There can only be one median and there can only be one mean, but there can be more than one mode. The mode is the value or values that occurs most often. So we'll say the value, I'll tack an S on the end of there because there could be values that occur most often. So let's take a look at example 1. In example 1, we're going to find the mean, median, and mode, and then we're going to decide which of these measures best represents the data. So we need to find them first, and then we'll decide, okay, based on this data, what do we think best represents it? So we're given a table of values here, and it says an amusement park hires students for the summer. The students' hourly wages are shown in the table below, and then we have all of the hourly wages. What we want to do is find the mean, median, and mode. So let's start with the mean. The mean is the average. And to find the mean, we take the sum of all the data values. Sum means adding, so we'll add all the data values and then divide by the number of values that there are. So it looks like we have 8 different values, so we'll add those all together and divide by 8. So use your calculator if you want, do it in your head, doesn't matter to me. We'll add them all, so I'm going to add 1650 plus 875. And you kind of get this. You can write this down if you want. I'm going to write it all down just so we know exactly what we're doing, but if you want, you can just go ahead and type this in right away. I'm just taking each of them. Make sure you don't miss any. Make sure you type them in right, because if you miss one, your data or your mean will not be accurate to your data. And one more, 925. Okay, so then after I add those all together, make sure you press equals on your calculator, then do divided by 8. You'll end up getting 965. So our average hourly rate is 965 an hour. Let's find the median. The median is the middle. In order to find the middle, I have to put them in order. In numerical order. So I'm going to start with 825. Just to kind of keep myself organized here, I'm going to cross it off as I do it. There's another 825. Put commas in between them so I can stay organized. There's an 845 and then an 865. 875 is next. And then I've got 910 and 925. And then lastly is the 1650. So you just have to find the middle, whatever way works for you. I'm a little bit more of a visual person, so I'm actually going to go and physically cross off one on each end until I get to the middle. So I'm going to cross off the lowest and cross off the highest. And then cross off the second lowest and second highest. And I'll keep doing that until I get to the middle. Now the issue here is there's two things in the middle. Well, remember earlier I told you there can only be one? There can only be one. So we have to figure out what to do with this. We're actually going to average those two. So to average those two, I'll add them together, get 17.4, divide by 2, and get 8.7. Or in this case, because we're talking about money, 870. So the median hourly wage would be 870. And then lastly is mode. Mode, probably the easiest to find, is the one that occurs most often. So I'll take a look at my list. It's usually easier to take a look at your list, your median list you made, because then you have them in order. The only one that occurs more than once is 825. It occurs twice, so my mode is 825. So the last part of this that I want to answer then, it says, which measure best represents the data? So there's not necessarily a wrong answer to this question, but there's probably a more right answer. So they all represent the data in some way. But if I take a look at these values and I take a look at all my data, I'm going to look at my mean first. My mean is 965. Now that's my average, and that's an important piece of information to know. However, it's higher than most of my numbers. So if you're trying to hire a student and you're telling them, hey, on average, we make 965, while that's true, you're going to have a lot of disappointed students because it looks like 5 of the 8 are making less than 965. Oh, no. Way more than 5. Wow, I can't count. It looks like 7 of the 8 are making less than 965. So that might not be the best measure for this because it really doesn't reflect the majority of the data values. I like 870 probably the best because 825, again, if you say most of the students make 825, you're not wrong. The most occurring hourly wage is 825, but it's also the lowest. I would say in this case, the median best represents the data because it's closer to most of the data values. So let's talk about why the mean is so much higher than all of our data values. If it's the average, why is it higher than all but one? One of the reasons that a mean can be higher or lower than most of our data is if we have an outlier. An outlier is a data value that is much greater or much lower than the other values in this set. Let's write that definition and then talk about what is the outlier in this example. So an outlier is a data value that is much higher or lower than the other values in a data set. So in example 2, it says, consider the data in example 1, identify the outlier. How does the outlier affect the mean, median, and mode? And then describe one possible explanation for the outlier. So the outlier, if I take a look up here at this data, the outlier is one that's either much higher or much lower than all the others. In this case, it's the 1650. So let's write that down really quick. The outlier is the 1650. Now, think about what that 1650 is doing. It plays a part in the average, right? Because it's a part of the data. You're adding it with all the others before you divide. It's making the average higher, okay? So if I were to find the mean without the outlier, it would be lower. So how is it affecting the average? It's making the average higher, making the mean higher because it's bigger than all the rest. Same with the median. Think about the median is the middle, and if I'm finding the middle here, that 1650 is an extra number that's all the way on the right side. If it wasn't there, my median would be a little bit lower, so it's making the mean and median higher. Now let's think about the mode. The mode was 825. If I got rid of that 1650, would 825 still be the one that occurs most often? The answer is yes. So it actually doesn't change the mode. So it makes the mean and median higher than they would be, but it doesn't affect the mode. Usually the outlier won't affect the mode, because think about an outlier is one that's way higher or way lower than the rest. Well, if there's more than one that's way higher or way lower, then it's probably not an outlier. It's probably just part of the data. So just think about that. And then the last one says, describe one possible explanation for the outlier. So let's think about this in terms of the real life example that it is. These are students' hourly wages at an amusement park. One student is making $16.50, while all the rest are making between $8 and $9. Why would one student make $16.50 when all the rest are making $8 or $9? Try to think of an explanation for that. So one possibility is that maybe that student is a manager. Maybe they have a little bit more experience. Maybe their job requirements are a little bit different. There's really a lot of different options. Again, probably can't have a wrong answer, but a couple different reasons for that. So pick whichever answer you like better and write that one down. Let's take a look at the next measure. The next measure we're going to talk about is the range. The range is the difference between the greatest and least values. The difference between the greatest and least values. In example 3, it says finding a range. We're given some data here. So let's take a look at what data we have. It says 2 reality cooking shows, select 12 contestants each. The ages of the contestants are shown in the table below. And then it says find the range of the ages for each show, then compare your results. So I have 2 shows. I'm finding the range for 2 things. Show A, I want to find the range, and show B, I want to find the range. So in order to find the range, I need to be able to compare the highest and lowest values. So I need to know the highest and lowest values. Be very careful here. Take a look at all of the ages in show A. I want you to find the lowest. Looks like it's 19. And I want you to find the highest. Looks like it's 31. We'll now subtract the highest, or the lowest from the highest, 31 minus 19. And I'll get a range of 12 years. So what that means for me is I know that all the contestants are within 12 years of each other. They range 12 years. Let's take a look at show B then. Same thing, lowest and highest for show B. Looks like the lowest for show B is also 19, but the highest is 48. So I'll subtract those two, 48 minus 19. My range here is a lot bigger. It's 29 years. So there's a larger range of ages for show B. Range can be useful for us. It can show us how spread out our data is. So it can be helpful in that. And then I kind of already said this, but the compare your results part, well, we know that show B has a greater range of ages than show A. Okay, the next thing we're going to do is standard deviation. So I went through mean, median, mode, and range and outliers a little bit quick because I don't think it's crazy difficult, and I think you guys will catch on pretty quickly. But we're going to talk about standard deviation. It's kind of a lot of work, so make sure you're ready on this. Make sure you have your calculator out. You'll probably want it. You'll definitely need it for one part. So let's talk about what the standard deviation is. So we have all these measures, mean, median, mode, range. But the standard deviation shows us basically how much a typical value in the data set differs from the mean. So we can have the mean. The mean is always the average. The standard deviation lets us see typically how close are the data values to that average. So the standard deviation is a measure of how much a typical value in the data set differs from the mean. So think about, we talked about scatter plots back in chapter 4. Think about in a scatter plot, if we had all these points and we had our line of fit. Do you remember the line of fit? Think about if this line of fit is the average, my standard deviation kind of allows me to see how close is my data to this line. So now I'm going to give you the steps for how to actually find the standard deviation. There's quite a few steps, so we'll write these down and we'll work through it. We're going to try to stay really organized and make some tables here. So make sure you're writing these steps, following along carefully here. The first thing, step 1, is to find the mean. And remember, we called mean x bar. We're going to find the mean. We know how to find the mean. We did that in example 1. Then we're going to take x. X would be our value, and subtract the mean from the value. So I'm using these notations here. X is our value, whatever it is, and we're subtracting the mean. So let's say the mean is 5. If my value is 7, I'll do 7 minus 5. Step 2, I'll get 2. That's called finding the deviation. It's not the standard deviation, it's the deviation. So in step 2, we're going to find the deviation. We do that by doing x minus x squared. Step 3, we're going to take the deviation, whatever it is, and we're going to square it. Okay. And then step 4, we're going to find the variance. Another vocab word for you here. The variance is finding the average of step 3. So we'll find the mean of step 3. And then our last step, step 5, is to take the square root of the variance. So square root, step 4, will square root the variance. So keep those steps in mind. We're going to go ahead and try example 4. So let's take a look at example 4. It says, find the standard deviation for show A in example 3. Use a table to organize your work and then interpret your result. So this using a table is actually going to be really important. It's not so much a suggestion as something that we really need to do in order to make sure we can keep track of what we're finding. So I'm going to walk you through how to find this table, and then from here on out, anytime I ask you to make or find the standard deviation, you're going to make the same table. So the first column of our table is just going to be x. That's just going to be our values. You can put them in any order you want, but we're just going to list them all. So let's fill in that column before we do anything else. My values for show A, I'm just going to go in the order they're listed. They're 20, 29, 19, 22, 25, 27, 27, 29, 30, 20, 21, and 31. So the first column, like I said, is just all the values. It doesn't matter what order you put them in. The second column is going to be the mean, so that's x bar. So we'll draw that, and I'm just going to leave that column open. We'll find the mean. The third column will be x minus x bar. So basically this column is saying, hey, take the first two columns and subtract them. And then I'll take that, x minus x bar, and I'll square it. So the last column, we're just going to square it. Then I'm going to take all of these numbers in the last column, and I'm going to find the mean by adding them together and dividing by the total. Okay? So let's find the mean first. To find the mean of these values, I'm going to add them all together and divide by, let's see, how many are there? 2, 4, 6, 8, 10, 12. There's 12. So I'll add all these together and divide by 12. So grab your calculator, start typing in 20 plus 29 plus 19. I want you to actually try this. Pause the video here and try this. Actually add these together. Actually divide by 12. Don't just wait for me to do it. Pause here and try it. Okay, after you've paused it and you've tried it, you should get that the mean is 25. If you didn't get a mean of 25, go back and check it. So the mean is 25. Now, this column is going to seem kind of silly, but the mean is 25 no matter what our x is. So 25 is actually going to be this entire column. The mean doesn't change. So again, it might seem redundant, but I want you to write 25 for each value in this column. The reason we're going to do this is because now we know, oops, I literally just told you to write 25 and I wrote 29. Let's actually write 25. The reason we need to write this is so that when we're doing our next column, which is subtracting, we have something to subtract. So my next column will be subtracting these two. It can be negative. 20 minus 25 is negative 5. That's what I'm going to put in my next column. Do you see how I got that? 20 minus 25. And then I'll go to the next row. 29 minus 25. That's 4. I'll go to the next row. You see the pattern? 19 minus 25. That's negative 6. So if you want, you can go through and do this, fast forward and see if you get the same numbers as me. 22 minus 25 is negative 3. 25 minus 25 is 0. And then 2, and then 2 again, and then 4, and then 5, negative 5, negative 4, and 6. So those are my variances. Nope, just kidding. Those are my deviations. I'll find the variance later by actually averaging the squared variances. So now I'll square each of those. Be careful when you square these. If you're going to use your calculator, you'll have to type in your calculator in parentheses negative 5 squared. You might know that already. When you square a negative, it becomes positive. So this actually becomes 25. Same thing, 4 squared is 16. Negative 6 squared is positive 36. This last column should always be positive because if you're squaring something, it's going to be positive. So negative 3 squared is 9. 0 squared is 0. 2 squared is 4. 4 again, 16. 25. 25, 20, and 36. Again, this column should always be positive because if you're squaring something, it's going to be positive. So now I'm getting closer. I need to now find the variance. This is step 4. To find the variance, I'm going to actually take all of these numbers and find the mean, the average. So grab your calculator and type in 25 plus 16 plus 36 and so on and so forth. Add all of these together, divide by the total, which is still 12. So I'm going to do this step by step. When I add all those together, I get 212. I divide that by 12 and I get 17.7. I'm almost done. That's the variance. I have one more step. The last step is to take the square root of the variance. So I'll grab my calculator and I'll do the square root of 17.7. My standard deviation after all of that work is 4.2. So what does that mean? We got a standard deviation of 4.2. Well, the standard deviation is the measure of how much a typical value in the data set differs from the mean. So we say the word typically. Typically, a value varies 4.2. What are we talking about? 4.2 what? Pigs riding airplanes? What? 4.2 looks like years, so we're talking about ages, right? So typically, a typical value is about 4.2 years from the mean. Okay, now that doesn't mean that every value is 4.2 years from the mean. A typical value is 4.2 years from the mean. That could be 4.2 years above the mean or 4.2 years below the mean. Okay, so that gives us kind of a measure of how close our data is to the mean. Obviously, a lower standard deviation means most of our data is closer to the mean. A higher standard deviation means most of our data is further away from the mean. We have one more example left. The last example we're gonna actually use all of this. We're gonna find the mean, median, mode, range, and standard deviation of the first example, but we're gonna do something to the first example. We're actually gonna increase each hourly wage by 50 cents. So you have two options here. You can turn your notes back to the first example. You can actually add 50 cents to each and find the new mean, find the new median, find the new mode, find the new range, and find the new, well, we actually never found the standard deviation. But I'm going to teach you a little shortcut here instead. One way that we can find the mean after each of the values is increased by 50 cents is to actually just take the mean that we found in example 1 and increase it by 50 cents. So back in example 1, we found out that the mean, or we calculated that the mean was $9.65. If I want to find the new mean, I'll add 50 cents to that. My new mean is $10.15. Same thing with the median and the mode. I can take the median we found, I can add 50 cents. I can take the mode we found, I can add 50 cents. So the median that we found was $8.70. I'll add 50 cents and I'll get $9.20. I can take the mode we found, which was $8.25. I can add 50 cents, that's $8.75. What I won't change is the range and standard deviation. Think about the range. It's subtracting the highest value, or it's subtracting the lowest value from the highest value. Well, the highest value is changing by 50 cents and the lowest value is changing by 50 cents. They're both changing. The difference between the two doesn't change. So the range should be the same. The range will still be highest value, which was $16.50, minus lowest value, which was $8.25. The mode will be $8.25 either way, even if I add 50 cents to that. If you don't believe me, do it. It's $17 minus $8.75. Hey, guess what? It's still $8.25. The range doesn't change. Okay, so range doesn't change. Same with standard deviation, because think about the standard deviation. That's telling me how far away a typical value is from the mean. Well, if all the values are changing, then all the values are still going to be the same distance from the mean. So let's go ahead and find the standard deviation. You might have enough room to do it right here. Make a little chart. My chart will start by listing my x's. This is the same chart we did in the last one. Then I'll list my mean. After my mean, I'll do x minus the mean. And then I'll square that. And then I'll find the mean of those numbers. So let's list all of our values. I'm just going to list them in order because I have them in order. 825, 825, 845. These are all the values from example 1. So if you're like, where the heck is she getting these numbers? It's from example 1. So those are my, oops, I wrote that last one wrong, 1650. Those are all my values, and my mean is 965. I'm going to save myself some time. I'm just going to draw an arrow, and then I'm going to subtract 825 minus 865 is negative 1.4. I'll get negative 1.4 again. I'll get negative 1.2, negative 1, negative 0.9, negative 0.55, negative 0.4, and the last one is 685. And then I'll square those. Remember, when you square something, it stays positive, so this will be 1.96, 1.96, 1.44, 1, 0.81, 0.3025, 0.16, and 46.9225. So I'll go ahead and average those now. So I'll add all of these together, divide by the total number, which is 8. So when I do that, I get 54.555 divided by 8, which is 6.819. Last thing is to square 6.819, or I'm sorry, square root. So my standard deviation is 2.61. That's going to be the same standard deviation if I increase everything by 50 cents. Let's take a look at part B. Part B is a little bit different now because we're asked to find the mean, median, mode, range, and standard deviation when each hourly wage is increased by 1%, in this case by 10%. So basically what I'm going to do is I'm going to multiply everything by my rate. Now be careful here. My rate, my R is 10%, which is 0.1. But I want to multiply it by my growth rate. Think about I'm increasing by 10%. Back in chapter 6, we talked about growth rate. Growth rate is the growth factor is 1 plus R. So in this case, my growth factor is 1.10 or 1.1. So what I'm going to do is I'm going to take my mean. I'm going to multiply it by 1.1. I'm going to take my mean. I'm going to take my mean. I'm going to take my median, I'm going to take my mode, and my range, and my standard deviation, and I'm going to multiply them all by 1.1 to get my new values. So my original mean was 9.65, I'll multiply it by 1.1, I'll get my new mean of 10.62. My old median was 8.7, I'll multiply that by 1.1, I'll get my new median of 9.57. My old mode was 8.25. I'll multiply that by 1.1. I'll get my new mode of 9.08. My old range was 8.25. I'll multiply that by 1.1 and get my new range of 9.08. My old standard deviation was 2.61. I just found that. I'll multiply that by 1.1 and I'll get my new standard deviation of 2.87. So when we're talking about a percent, we multiply everything by that percent. When we're talking about increasing by a value like 50 cents, we only add it to the mean, median, and mode, not the range and standard deviation. So make sure you know the difference between that. All right, when you're done with this, make sure you've written everything down, send me a picture, and then you can go ahead and get started on the assignment for this.